Hello guys, welcome to the tutorial one. So in the previous class we saw some formulas and today we are going to solve some questions based on that. So what we did, okay, so let us quickly revise that all and then let us understand that. Okay, so the first thing is that we understood about the so which book you want to study. So that is GATE. Okay, and then we understood about the load, the tensile load, and the compressive load, and then we understood about the sigma. Okay, that is the stress. Okay, and this sigma is uniform in nature, and so when we say like this sigma is equals to p by a like this in the exact form, then this means that this load is acting at the center of gravity CZ or at the neutral axis. Okay, now then load is the any external force or the external moment. Okay, and we have seen this. Okay, and let's say that if something is like that. Okay, so if I say sigma is equals to limit delta A tends to 0, and if I write it like this, uh, so I may write it like this, some function of x and y. So I may write it like this: p as a function of x and a, okay, as a function of x or something like that. Okay, so so when or I can transform like this. So by dx, something like that. Okay, now then this is the load and all. Okay, and then we have seen the stress tensor. So I represents the phase and J represents the direction, and then we have seen three stresses: sigma xx, sigma yy, sigma zz, and then we have sigma xy, sigma xz, sigma xy, sigma xz, sigma yx, sigma yz, sigma zx, sigma zy, and all. And then we have seen that the stresses are like symmetric in nature, that is A transpose is equals to A. Okay, and we have seen these are the 6 shear stresses and these are the 3 normal stresses, and we have seen that the symmetry of the stress tensor is derived from the moment equilibrium, that is sigma xy is equals to sigma yx, sigma xz equals to sigma zx, and sigma yz equals to sigma zy. Then this is the stress system in the 2D system. Okay, so stresses in 2D. Okay, so that is sigma xx, sigma xy, sigma yx, sigma yy. Okay, and these are the sigma xy, sigma yx, so these are equal. Okay, and this is the sign convention that we are going to use. Okay, for the shear stress. Okay, and for the normal stress, so plus minus, then this is the sign convention that we are going to use for the inclined plane. Okay, so stresses on an inclined plane, we have seen that. Okay, so we use this as a plus, and in some book GATE and all, if you study GATE and all, then you will see that this is, they consider that plus. Okay, but we consider this as a minus. Okay, minus means opposite direction or the inverse direction. Okay, now then we have seen some formula sigma and theta. This is important one, so you should remember this one. Okay, this formula is actually important, so you should remember this formula, and this one as well, and this one as well. So these formulas are important, so you should remember them. Sigma and theta, sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 cos 2 theta plus tau xy sin 2 theta. Then we have tau s theta, that is sigma x minus sigma y by 2 sin 2 theta minus tau xy cos 2 theta. And then sigma and 90 plus theta, so replace 2 theta by 90 plus theta, and we will get that. Okay, and then here is sigma x plus sigma 2 t is equals to sigma x plus sigma y, or this is equals to sigma x dash plus sigma y dash. Okay, then we have seen the principal planes. Okay, So location of principal planes, so this is given by this formula, tan 2 theta is equals to tau x by sigma x minus sigma y by 2. Okay, and then we have seen that there will be 2 theta, theta 1 and theta 2, and then the major principal stress and minor principal stress. So that is the algebraically largest value will be the major, and algebraically smallest value will be the minor. So you can see sigma 1 is 20 and sigma 2 is minus 80. Although this means that if I say sigma 2 is 80, this means that it is like this. Okay, so this is 20, this is 20, this is 80, this is 80, but we are going to call this one as sigma 1 and this one as sigma 2. Why? Because this sign algebraically the larger value will be the major or maximum, and the smallest value will be minor or minimum. Okay, so that is algebraically. So this minus sign will represent that this is algebraically a smaller one and this is algebraically larger one. Okay, we are not going to see only magnitude, we are also going to consider this sign as well. Okay, but although this sign means that this is in the inverted, like it is compressive in nature and all. Okay, and then this is the formula, major principal stress and minor principal stress. This is minus and this is plus. Okay, so there are two plus minus and all. Okay, and this is itself is called as the resultant r or the tau max or the radius of the curvature. Okay, so we will see about that in the Moore circle. Okay, today. And now sigma and star. So this is the like principal planes. Okay, sorry, normal stresses on the planes of maximum shear stress. Okay, so on planes of maximum shear stress, like normal stresses will be equal and non-zero. Okay, and if we have understood all these things, then there is the like maximum shear stress tau max. Okay, and tau max is sigma 1 minus sigma 2 by 2, and then tau max absolute. Okay, and then there are some stress area functions, so these are called the stress area function. Sigma xx is equals to dou square phi by dou y square, sigma y equals to dou square phi by dou x square, sigma xy is equals to minus dou square phi by dou x dou y. Okay, and then similarly so this is the equilibrium equation. Okay, with presence of body force. Okay, so and when there is no body force, then this term will vanishes, and if I say 2D, then z forces in that z direction, sigma z will be 0. So this all that has the z in it will be cancelled out. So what we are left with? We are left with sigma xx by sigma dou x, dou sigma x by dou x plus dou sigma x by dou y plus dou sigma xz by dou z. So guys, these formulas are very important, you need to remember this. Okay, so you cannot forget this if you want to score good marks in the GATE. Then there is a compatibility equation. Okay, so dou square sigma xx by dou x square plus dou square sigma y by dou y square plus dou 2 times dou square sigma x by dou x dou y is equals to 0, and it is given by del square sigma x plus sigma y. That was the okay, and then this is the stress area function. Okay, so phi is, let's suppose that phi is any stress area function, then del ki power 4 phi by del x ki power 4 plus del ki power 4 phi by del y ki power 4 plus del ki power 4 phi by del square x del square y is equals to del x square del y square. Okay, actually is equals to 0, and it is given by del ki power 4 phi is equals to 0, and this is the biharmonic in nature. Okay, and this is the equilibrium equation, that is dou sigma xx by dou x plus dou sigma xy by dou y plus dou sigma z by dou z plus x. So this x is the body force per unit volume in the x direction, and this is 0. Then dou sigma yx by dou x, dou sigma y by dou y plus dou sigma yz by dou z plus y. So body force in y direction per unit volume. And similarly dou sigma zx by dou z plus dou sigma zy by dou z dou y plus dou sigma zz by dou z plus z, body force in z direction per unit volume. And in the absence of body force and no shear 2D, this was for 3D, so in 2D, then this part will get cancelled out, then we will have two equations. Okay, so dou sigma x by dou x plus dou sigma x by dou y plus 0. So this x is 0 because there is no body force. Okay, similarly dou sigma yx by dou x plus dou sigma y by dou y plus 0 because this body force is absent there, so there is no body force in y direction. So that is, so this is how it is. Okay. Now then, we have already seen something. Okay, and so let us see some formula, sigma 1 and sigma 2. So what is that? Sigma x plus sigma y by 2. Okay, and then plus minus under root of sigma x minus sigma y by 2 whole square plus tau xy whole square. Okay, that is the principal stresses formula. Okay, and not only that, so for principal planes, okay, so location of principal planes, how can we find out? Tan 2 theta is equals to tau xy by sigma x minus sigma y by 2. Okay, and uh, planes of shear planes. Okay, shear planes of maximum shear or in planes of shear plane. Okay, so how can we find out that? So tan 2 theta is equals to sigma y minus sigma x by what can I do? Sigma y minus sigma x by 2 tau xy. Okay, so that is the location of shear stress or location of principal planes for shear stress. Okay, maximum shear stress. Okay, and then there was one more thing, tau maximum. So that would be sigma 1 minus sigma 2 by 2 mod of sigma 1 minus sigma 2 by 2, or we can write simply this term as tau max. Okay, or we can write it as under root of sigma x minus sigma y by 2 whole square plus tau xy whole square. Okay, so like this, and then there are some stress area function and all. So what are those stress area function? So let me erase this. So then we have seen that tau max. Okay, now so sigma s plus sigma t is equals to sigma x plus sigma y is equals to sigma x dash plus sigma y dash. Okay, so this holds true, and not only that, sigma n star. So this is the location of normal stress on the planes of maximum shear stress. Okay, so what is that? Sigma x plus sigma y by 2. Okay, so on planes of maximum shear stress, okay, normal stress will be equal and non-zero. Okay, so this is very important, you have to remember this one. Okay. And then we have seen the formula of sigma and theta, that is sigma x plus sigma y by 2 and plus sigma x minus sigma y by 2 cos 2 theta plus tau xy sin 2 theta. Okay, so you have to remember this formula as well. And then there is tau as theta. So what is that? Sigma x minus sigma y by 2 sin 2 theta minus tau xy cos 2 theta. Okay, so you have to remember this formula as well. Okay, so you can see this one, and then okay, and then we have the stress area functions and all, so we will revise that as well. So sigma xx stress area function is given by dou square phi by dou y square. Okay, and sigma yy is given by dou square phi by dou x square. Okay, and sigma xy is given by minus dou square phi by dou x dou y. Okay. And then we have another thing, that is the equilibrium equation. Okay, in the presence of body force, so how do we write that? Dou sigma x by dou x plus dou by dou y sigma xy plus dou sigma xz by dou z plus x body force per unit volume in the x direction is equals to 0. Similarly, we have another dou sigma, uh, sorry, this is xx and this is xy by dou x plus dou sigma yy by dou y plus dou sigma yz by dou z, y face z direction. Okay, plus body force in y direction equals to 0. And now like sigma ij. Okay, so this represents the face and this represents the direction. Okay, so like I have three axis system, x-axis, y-axis and z-axis. Okay, and I have this body. Okay, so this is my x-axis, this is my y-axis, and this is my z-axis. Then in x face and z direction, so this is sigma x-axis, like this. So this is how we give the symbol to all these things. Okay, now then there is another equilibrium equation, that is dou sigma zx by dou x plus dou sigma z face y direction by dou y plus dou sigma z face z direction by dou z plus body force in z direction per unit volume. So this is the equilibrium equation. Okay, and when I say that the body force is absent, body force in the no body force, then this is 0, this is 0, this is 0. And when I say 2D, then this becomes 0, this becomes 0, this becomes 0, this becomes 0, and this becomes 0. Then what we have left with? This one and this one. So these are for the 2D and no body forces. So when I say 2D and no body force, okay, and when I say 3D and with body force, so this is 3D with body force. Okay, and it has the body force. Okay, so it has the body force. Okay, so this is the equilibrium equation. And if I say talk about the compatibility equation, then what is that? Dou square sigma xx by dou x square plus dou square sigma yy by dou y square plus 2 times of dou square sigma xx by dou x dou y, and this is equals to 0. So this is the compatibility equation. Okay, this is the compatibility equation. And then there comes one another thing, that is del square 4 phi is equals to 0. Okay, and this equation is biharmonic. So if I say this, then what does that means? Del की power 4 phi by del x की power 4 plus del की power 4 phi by del y की power 4 plus del की power 4 2 times of del की power 4 phi by, sorry, not 2 times. Okay, so del की power 4 phi by del x square del y square, and this is equals to 0. So guys, that is this is equals to 0. So that is the stress area function phi. So phi is stress area function. Okay, so we have understood all those things and we have revised all those formula. Now, so this is our first question. So the question says that a parallelogram, say plate of dimension A and B as shown in figure, is subjected to a uniform loading of normal stresses sigma 1 and sigma 2 the plate is in equilibrium for. So they're subjected to uniform loading. Okay, so loading is uniform in nature, so you can write sigma is equals to P upon A. Okay, and they are asking that how this is equal and all. Okay, so what should be the correct option out of this? Okay, so we have like this, we have something like this, and this angle is theta. Okay, and we have something perpendicular to this, that is sigma 2, and we have something perpendicular to this, that is sigma 2. We have perpendicular to this, that is sigma 1, and we have perpendicular to this, that is sigma 1. And as clearly as you can see, this length is b, so this length will be b sine theta. Okay, and clearly you can see, so there will be another, that will be b sine theta, similarly like that. Okay, now then if I take this part, okay, so if I take this part, so this is 90 degree and this angle is theta, so this is 90 degree. Okay, this angle is theta and there is sigma 2, so this is sigma and theta. Okay, and you can clearly see this side is b. Okay, and you can clearly see this side is b. Okay, and this side is sigma 1. Okay, this side is sigma 1, this side is sigma 2, and if I take a line like this, this line is parallel to this line, so this is intercept, so this angle will be theta, then this angle will be 90 minus theta, then this angle will be theta. Okay, and right, so let me draw this one with the black line, so this and this, so this is sigma 2, so this will be sigma 2 cos theta. Okay, and this will be sigma 1. Okay, so we have to find out the relation between sigma 1 and sigma 2. Okay, so now this is the sigma 2 cos theta and this is sigma 1. Okay, and they are saying the loading is uniform, so I can write P is equals to sigma times A, right? So load is equals to sigma times A because this is the uniform loading. And guys, this is the like parallelogram. Okay, so let's imagine, so they have not given anything about this thickness, okay, about this particular figure. So let's say that the thickness is equals to 1. Okay, so what will be the area of this face? Okay, so area of this face and all. So this length is b, so what would be this length? This length will be b cos theta. Okay, so this angle is theta and this length is b, then this length will be b sine theta. Okay, sorry, so this length will be b sine theta and this length will be b cos theta. Okay, and let's say this length is b. Okay, so b cos theta and thickness is 1, so into 1, so this will be the area of this side, so this will be the area of this base, and b sin theta into 1, so this will be the area of this face. Okay, that is clear. Is it clear to you guys? Is it clear to you? This is nothing but pure mathematics. Okay, there is nothing but transformation and mathematics. Okay, so you need to understand this one only. Okay, now then so sigma 2 cos theta into like b cos theta into, so let me say, so what will be that? Sigma 2 b cos theta into 1, so that will be the load in y direction. So what we are going to do is that we are going to do summation of forces is equals to 0. We are going to balance the force equation. Okay, and b cos theta into 1. So force is equals to sigma times a, so we are going to balance out the forces in y direction. So summation of forces in y direction is equals to 0, and what is that? Sigma 2 into b cos theta is equals to sigma 1 into b cos theta, and this b cancel, this cos theta cancel, so sigma 1 is equals to sigma 2. That will be your answer. And see, it is quite easy, very easy, very easy. Okay, and this question has been asked in GATE. Okay, this is the question that GATE has asked. Okay, so the important thing is that you should keep your mind cool and calm, okay, in the examination. And then the second thing, you should like understand about this, that sigma is equals to force per unit area. Okay, and then you have to like make the summation of force is equals to 0. We have three tools: summation of force in x direction 0, summation of force in y direction 0, and summation of moment about any point is 0. So you can use either one of the tools from it. Okay, and then you can try to solve it. Second thing is that you have to understand that if they have not given you the thickness, so let's say that this is the body, so if they have not given you the thickness, okay, then you have to imagine that thickness is equals to 1. Okay, so you have to take that into account, and then you have to find out the area. Okay, so area for this one and area for this one. Okay, and then you have to resolve this forces, then you have to resolve this length and forces, and then you have to find out that area. Okay, so is that clear to you? If that is clear to you all, then this is very easy. Okay, it is not very difficult. Now then the next question. So you can see this question has been asked in 2010. So falling stress state is proposed for a 2D problem with no body forces. So they are saying no body forces. Okay, and they have given you sigma xx is equals to 3x square y plus 4y square. They have given you sigma yy is equals to y cube plus 14xy, and they have given you tau xy is equals to minus 3xy square minus 7x square. It satisfies, so they are asking whether it satisfies the equilibrium or compatibility or not. Okay, so we already know equilibrium equation with in the absence of body force, and for 2D, so what would that be? Dou sigma x by dou x plus sigma xx dou sigma xy by dou y is equals to 0. Okay, and then there is dou sigma yx by dou x plus dou sigma yy by dou y is equals to 0. So these are the equilibrium equation. And what is the compatibility equation? So compatibility equation is dou square sigma xx by dou x square plus dou square sigma yy by dou y square plus 2 times dou square sigma xx by dou x dou y is equals to 0. So this is the compatibility equation. Okay, so now you know what you have to do. You just have to differentiate this one with respect differentiate this. Okay, and then you have to find out whether they can satisfy the equilibrium equation or not. Okay, so let's do the differentiation. So dou sigma x by dou x. Okay, so dou sigma xx by dou x, what does that give? 3 to the 6x. Okay, from here, so 3 to the 6x y plus 0. Okay, so this one will get 0, and dou sigma dou sigma y by dou y, what would that give to you? Dou sigma y by dou sigma xy by dou y, so this one. Okay, dou sigma xy by dou y, so what would that give you? Minus 6xy. Okay, and plus 0. Okay, so if we add this two, so this is 0, so definitely this satisfies the continuity equation, dou sigma x by dou x plus dou sigma xy by dou y. Okay, So if we add this, then this is going to be 0. So definitely this satisfies the equilibrium equation. So let us check for the compatibility equation. Okay, so compatibility equation, dou square sigma x by dou x square. So dou sigma x by dou x, and if I do dou square sigma x by dou x square, then what would we get? 6y. Okay, and if we find out dou square sigma y, so let's find out dou sigma y by dou y first. So what would that be? 3y square plus 14x and dou square sigma y by dou y square, so that is 6y plus 0. Okay, and if we add this to uh, and so this is dou sigma y, dou square sigma y by dou x square, this is dou square sigma x by dou x square, plus we have to also find this one as well. So we already have dou sigma x y by dou y. So this is dou sigma x y, not dou x. Okay, sorry. So that is dou sigma x y by dou x. Okay, so we already have this one, dou sigma x y by dou x dou y. So we have to differentiate it with x. So dou sigma x y by dou x dou y, and if we differentiate it with respect to x, then what it will be? It will be minus 6y, right? It will be minus 6y, right? Definitely, because we are differentiating with respect to x. So x will go then minus 6y. Now if you add this one plus this one plus this one, so this one and this one cancels, but still this one is remaining. Okay, so it it satisfies the equilibrium. Okay, it satisfies the equilibrium, but compatibility, it does not satisfy that. Okay, so equilibrium equation but not compatibility equation, so that is your answer. Okay, now then there is another question. Okay, so this is again 2010, and you can see they have been asking questions from the stress area function. Okay, so the question is, the thin rectangular plate shown in the figure. Okay, so thin rectangular plate shown in the figure is located with uniform shear torn out. Okay, so this is the figure. Okay, and they have sigma naught and they have tau naught. Okay, so they have sigma naught and they have tau naught. Okay, and you know our sign convention is like this. So if our shear stress is like this, then this is plus, and if our shear stress is like this, then this is minus. Okay, minus tau. Okay, so our sign convention actually matches this one. Okay, so there is no problem with this, and this is again sigma naught and this is again tau naught. Okay, so this is tau naught. So we have this one. Okay, and along all the edges and uniform uniaxial tension in the y direction, the appropriate average stress function to solve for the stresses given y. So they are asking the appropriate stress area function, so that we can solve this one. Okay, so this is very easy. Okay, so there are two things that you can do. Okay, you can either see these options, okay, and then try to solve or compare, or otherwise you can use that. So how does we represent sigma xx? So that is dou square 5y. Okay, dou y square. Sigma y, how does we represent that? Dou square 5y dou x square. Okay, and how does we represent sigma xy? That is minus dou square 5y dou x dou y. Okay, so this is how we represent the stress area functions. Okay, so this is how we represent the stress area function. Now you can see there is no sigma x, so this will definitely go to 0, so there is nothing. but there is sigma y, and you can see sigma y is should be the function of sigma x square. Okay, so sigma y should be the function of x square. Okay, so there should be x square for the sigma y, and then you can see sigma x, sigma xy or the tau xy should be the function of xy. So sigma y is the sigma node and the tau xy is the tau node. So tau node should be the function of xy and sigma node should be the function of x square. Okay, now let us see in this one. The tau node is xy. Okay, and definitely it is the minus, so that is fine. Okay, it does not matter, but our stresses are our stresses should be like so uh, it should be positive. Okay, because tau node is positive. Okay, so if we have this one in negative and if we differentiate it, then again it would become negative, negative, positive. It does not matter at all. So you can see minus sigma naught x square, okay, plus sigma naught x to the power 4 minus y to the power 4. Actually it is also the function of y. Okay, so it should not be there. Then there are so this will again get cancelled as well. Sigma naught is the function, sigma naught should be the function of x square. Okay, and it should be positive. Okay, so tau naught xy minus sigma naught x square by 2 minus, but this is the plus. Okay, and this is like minus. Okay, so it should be minus. Okay, so minus tau naught xy plus sigma naught x square. Okay, so this looks reasonable. Okay, so if you differentiate this one, okay, so so this looks reasonable. Okay, uh, so this should be the correct answer, because there is like sigma naught is positive. Okay, so like this is sigma yy should be the positive sigma naught, this should be the positive function of x square. Okay, not the negative. Okay, so that is why C should be the correct option, and this is also gone. So you can see how they are like asking cleverly, they are asking you the questions. Okay, so the important thing is that you need to keep calm in the examination. Okay, keep calm. Okay, don't get panic. Okay, read the entire question and try to see what they are asking you, and then you can definitely solve these questions. Okay, is that clear to you? This is very easy, this is not difficult at all, you already know everything. Okay, now then there is next question. Okay, so again the next question is same. So we have something. Okay, so that is sigma yy, and let's say this is q, and then we have something that is sigma xx, and let's say this is p. Okay, and we have something tau xy, and let's say this is r. Okay, and they are asking that what should be the which of the following array stress function could satisfy the given boundary conditions. So they are asking which uh, like what should be the value of phi so that it should be satisfied. Okay, so you already know phi should be something like that. So let us see. Sigma xx is equals to dou square phi by dou y square. Okay, and sigma yy is something dou square phi by dou x square, and tau xy is minus dou square phi by dou x dou y. Okay, and from the previous question now you already have the experience. Okay, so you can see sigma xx is what? Sigma xx is p, so p should be the function of y square. Okay, from because there is y square. Okay, if it is not y square then it will get 0 because you are differentiating it 2 times. Okay, make sense? So p should be the function of y square. Okay, and not only that, sigma yy is the q, So q should be the function of x square, okay, that is sigma yy, and then this one, so this one should be the function of minus xy, okay, so r should be the function of x y and it should be negative. So let us see which one matches our option. So p is the function of x square, so this one is gone. P is the function of x square, so this one is again gone. Okay, now what we have, b and c. So p is the function of y square, p is the function of y square, okay, so that is true, it's fine. Q x square by 2, x square by 2. Here r is plus xy and r is minus xy, so this should be the correct option. Okay, so r should be minus because this is negative. See, it is very easy and very simple. There is nothing difficulty in this one. Okay, now let us move on to the next question. So the next question is the array stress function phi. So you have been given phi is equals to this is alpha x square plus beta xy plus gamma y square. Okay, so this is phi. Phi is given and they are saying for thin square panel of size L cross L. So this is a square panel, okay, and thin. So this means that thickness. Let us assume that the thickness is 1. Thickness is equals to 1. Let us assume if the panel is subject to uniform tensile stress on all four edges. So tensile stress means this one, sigma naught, and sigma naught. Okay, the traction boundary conditions are satisfied. So they are asking you the boundary condition again, you know. So sigma x is equals to dou square phi by dou y square, and this is equals to sigma naught. Sigma x is sigma naught, right? This should be the sigma naught. So sigma naught should be the function of y square as well. So correct. Okay. Now then they are also asking us the values of all these alpha, beta, and gamma. So sigma yy, what would be that? Dou square phi by dou x square, and this should again be the sigma naught. Sigma yy is the sigma naught, okay, because the sigma naught is the only stress. So uniform tensile stress on all four edges. So sigma naught on all four edges. Okay, so this is the edge, this is the edge, this is on all four edges. So that is why sigma naught is again sigma yy itself. So sigma naught should again be the function of x square. So sigma naught should be the function of x square and y square both as well. Okay, then sigma x, sigma y, and then there is sigma xy. So this should be minus dou square phi by dou x dou y, and this is the shear stress. So there is no shear stress. So this should be 0, right? This should be 0, and this is your so this should be 0. Okay, now then if you if you compare, okay, if you compare this one, so let's say, so you can see sigma yy is the function, sigma naught is the function of x square, and sigma xy is the function of 0, okay, and sigma naught is the function of y square as well. So alpha x square, so this is the x square, so x square is the function of sigma naught, so this should be the sigma naught. Okay, well so alpha should be sigma naught, beta again should be sigma naught. Okay, beta again should be same thing, sigma naught, and then gamma sorry, so beta is the function of xy. Okay, so let me erase, beta is the function of xy, so this should be 0 because the function that has the xy, that is 0, that comes 0. Okay, so beta should be 0. Then gamma is the function of y square. Okay, so y square again, this should be sigma naught. Okay, so beta should be 0, gamma should be sigma naught, and alpha should be sigma naught, because this should be equal. By differentiating this one, you can already find out. Okay, so alpha is sigma naught, gamma is sigma naught, and beta is 0. So this one satisfies it. Okay, and rest are not satisfying this one, right? So this is sigma naught by 2, 1 sigma naught by 2. So these are not satisfying it. Okay, is it clear to you? Now then, let's move on to the next question. In general, for any given solid subjected to arbitrary loading, which of the following statement is always true? So volume does not vary with loading, mass does not vary with loading, density does not vary with loading, volume, mass and density vary with loading. So let's say I have a body and I'm applying a simple tensile stress, then its length will change. If there is a deformation in the body, then its length will change, and if length changes, then its volume will change. Okay, so if length is changing, then volume will also change. Why? Volume is area times length. Okay, so volume is also going to change, and if volume is changing, then density is also changing. Why? Because volume is inversely proportional to the density, or you can say density is equals to mass times volume. How can I write it? Okay, wait. So density is equals to mass per unit volume. Okay, so there is only one thing that is not changing, that is the mass of the object. Okay, so well, if this particular object is of 1 kg, well, if you stretch it, if you compress it, this 1 kg will remain unless and until you don't cut out some part and remove. Okay, so the mass remains constant. So mass does not vary with loading. Okay, then there is another question. Okay, and you can see there are some direct questions that are being asked. Okay, so which of the following object with inclined face at 45 degrees subjected to the given stresses are in static equilibrium? So they are saying, this is option A, option B, option C, option D, which one is in equilibrium? Okay, so first thing first, notice this one and this one, this one and this one, this one and this one, this one and this one. So if you notice it, then you will notice that sigma x is equals to 30 megapascal. Okay, and sigma y is equals to 40 megapascal, and that is true for all these things. Okay, and you will also notice that theta is equals to 45 degree. Okay, so now then they are asking you the value of sigma and theta and tau as theta. So these two value they are asking, because this is sigma and theta, this is tau as theta. Okay, is that clear to you? So if you have understood this much part, then what is the formula of sigma and theta? You already know, right? Sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 cos 2 theta plus tau xy sin 2 theta. So this is the formula for sigma and theta, right? Now what is tau as theta? So this is sigma x minus sigma y by 2 sin 2 theta minus tau xy cos 2 theta. Okay, minus tau xy cos 2 theta. So that is this one. Okay, now then you can see you can easily apply the formula, right? You can easily apply it. So theta is equals to 45 degrees, so cos 2 theta will be cos 90 degree, so this will become 0. Okay, and sin 2 theta will become 90 degrees, so sin 90 degree is 1, so this value will become 1 and this value will be there. Okay, so what can you write? Sigma and theta is equals to sigma x plus sigma y by 2. So sigma x is 30 and 40, 30 plus 40, 30 plus 40 by 2 and plus tau xy into 1. So this is 1. Okay, sin 2 theta is 1, tau xy is tau xy is present there, no tau xy is there, so this will again become 0. Okay, this is 0. So 30 plus 40 is 70 by 2, and this is equals to 35. So this is equals to 35. So this will go, this will go, okay, and this will go. Okay, so what we have, 35, 35. Okay, now we have to check for the tau s theta. So tau s theta is sine to theta, cos to theta. This part will go. Sigma x minus sigma y by 2. So what is that? Sigma x is 30 and sigma y is minus 40. Sigma x, uh, sigma x is minus sigma y is 40. So by 2. So minus 10 by 2, that is equals to minus 5. So minus 5. So this means, our sign convention was that if it is minus, then tau s theta will be in upward direction, and this is plus, and this is tau s theta. So this should be, our sign convention was like that. So if it is plus, then tau s theta will be in downward direction. Okay, but if it is in minus, if it is in minus, sorry, if it is in minus, then tau s theta will be in upward direction. Okay, okay, so it would be upward direction and its value will be 5. So this one is in the downward direction, so this will get cancel out. So what we have, this one is, okay, so that is correct. Is that clear to you? It's very easy, very simple. Okay, you just have to remember the formula, and then you just have to put all those values. Okay, now then, there is this one, another question, that is, you have been given phi is equals to c1 xy plus c2 xy cube plus c3 x square y square plus c4 x cube y. Okay, and okay, so this is phi. Now let us read the question. A cantilever beam is subjected to a parabolic distribution of shear traction at the right edge, so at here. Okay, while the top and bottom surfaces are traction free. To solve this problem, following array stress function is proposed. So this stress function is given to you. An admissible arrays function that this is an admissible arrays function that would satisfy the biharmonic equation as well as the boundary condition if and only if. So they are asking you the values of c1, c2, c3, c4 simply. Okay, and they have given us tau xy. So sigma x is equals to 0, sigma y is equals to 0, and tau xy is equals to minus lambda times. So from here, 1 minus y by d whole square. Okay, so this is tau xy. So if I simplify it, this is minus lambda minus plus lambda times y square by d square. Okay, so that is, I have opened it. Okay, I have simplified this one. That is tau xy. Now then, what is the value of tau xy? So let us see. Tau xy is equals to minus dou square phi by dou x dou y. Okay, so let us first find out dou phi by dou x. So what would that be? Dou phi by dou x, c1y plus c2 y cube plus c3 twice of x y square plus 3 times c4 x square y. Okay, and now let us find out the dou square phi by dou x dou y. So from here, so we are differentiating now with respect to y. So this will become c1 plus 3 times c2y square plus 2 to 4 times c3xy plus 3 times C4 x square. Okay, so that is okay. So this is dou square 5 by 2 x square, and if we find out and what we have, so this is equals to minus tau xy. Okay, because this is like minus, so minus and here, so this is okay. So this is minus tau xy and this is tau xy. So let us compare both the equations. Okay, so let us compare. So what I will do is that I will make it plus and I will make it minus, 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 minus. Wherever there is plus, replace it by minus, because this is minus. Okay, so this becomes plus and this all this become minus. Okay, now let us see. So minus c1, so minus c1 is equals to minus lambda. If you compare, minus c1 is equals to minus lambda, so this implies c1 is equals to lambda. Okay, then this is the function of y square. So which one is the function of y square? This one is the function of y square. So 3c2 is equals to lambda by d square. Okay, so from here you will get c2 is equals to lambda by 3 d square. Okay, and then xy, so there is no function of xy, so c3 is equals to 0. X square, there is no function of x square, so c4 is equals to 0. Right, now let us match the option. So c1 is equals to lambda, c1 is equals to lambda, so it is here and here. Okay, and c2 is equals to lambda by 3d square, so c2 is lambda by 3d square, and it should be minus or plus. So let's see, this one is minus. Okay, so minus, so this should be minus, so this should be minus, and this one is plus, so this should be minus. So this one will get cancelled out and this one will be true. Okay, and c3 is 0, c4 is 0, c3 is 0, c4 is 0. Check for the sign, negative and positive sign carefully. Okay, and then you will find the correct answer. If that is if you understand that, it is very easy. Okay, this is nothing difficult. Okay, you just have to find out and then you just have to compare. Okay, now let's move on to the next part. So the two non-zero principal stresses at a point in a thin plate are, so they have given you sigma 1 25 megapascal and they have given you sigma 2 minus 25 megapascal. The maximum shear stress, so they are asking tau max. Okay, so you already know mod of sigma 1 plus sigma 1 minus sigma 2 by 2. Okay, so what would that be? Mod of 25 minus 25 by 2, and that would be mod of 50 by 2, and this is equals to 25. Okay, so tau max is 25 megapascal. Okay, so if you understand that, then let us move on to the next question. Okay, so the next question is, a cylinder structure is subjected to 4 different loading cases as shown below, figure not to scale. Okay, which pair of cases result in identical stress distribution at section SS located far away from both ends? So we already know that if the load is applied at any point, okay, and if we take a section at some, so let's say that this distance is x, which is greater than 3 times d, then the stresses will be uniform in nature. Okay, so that is why they have said that uh, located far away. So section SS is located far away from the point of, if it was asking there, then it should be have, it would be parabolic and there it would be uniform. Okay, so but our concern is not whether it is parabolic or not, or uniform or not. Our concern is that what they are asking. So they are asking you that identical stress distribution. So like which one of these are like identical or correct? Okay, like, so well, which one of them are correct, identical, all of them are correct, but which of them is identical, like which of those are like matching each other. Okay, so first one is very simple. So you have a body, okay, and you have fixed it with one end, and then you are applying some load from the CG point, okay, and that load is P, and this is the section SS. So there the stresses will be uniform in nature. Well, now then there is another one. So this is first one, this is second one. So in second one again, you have this body, same body, and this is the like, let me draw it with dashed line, and then you have, so on top of it 3p by 8, and then you have p by 8. In bottom again you have p by 8. This is 3p by 8. So what is the total load that you are applying on this body? So you will have to add all this. Okay, so 3p by 8 plus p by 8 plus, sorry, forgive me guys, so let us write it neatly. 3p by 8 plus p by 8 plus p by 8 plus 3p by 8. So what would that be? 8, 3p plus p plus p plus 3p. 3, 3, 6 to 8. 8p by 8. And this gives you exactly p. Okay, but don't forget one thing. So this is p and here is also p. Okay, but are they equal or not? So don't forget that. Okay, this one more thing, one important thing. Okay, that is, they are not at the central point, but this load is at the central point. So let us now check how to like, can I bring them to the central point or not. Okay, so see this, let's say that this distance is a, and this distance is again a, because they are equidistant from each other. Okay, so if I like, apply a pseudo moment, so let's say that my body is here and there is, this is the neutral point and there is p by 8. Okay, then what would happen, what would happen, this p by 8, I bring it to the neutral point, then I will bring it like that, p by 8 and p by 8, and there is some distance between them, let's say a. So this p by 8 and this p by 8, this will generate a moment in this direction. So there will be a moment. So there will be a moment in this direction between the central point and this p by 8. Similarly, there will be a moment in this direction by this p by 8, and this moment and this moment will cancel each other. Okay, because this is in this direction anti-clockwise, sorry, clockwise direction, and this is in anti-clockwise, they will cancel. Similarly, so if I have 3p by 8 here from this one and 3p by 8 here, then again this will generate a moment in the clockwise direction, and then again because of this there will be a moment in anti-clockwise direction. So finally all summation of moment will be 0. This means that all the moment will get cancelled out. Okay, so we can say that this figure is actually identical to this figure. If we bring out all those load at the center, okay, this 3 by p by 8, this 3p by 8, and this p by 8, this p by 8, all the load at the center, then we can definitely make it equivalent like this. So the p is acting, and all the moments that is like in clockwise and anti-clockwise as well, all the moment is cancelled out. So okay, so all the moments cancel out each other. So there is no moment being applied onto this body, and then I can say that this one and this one is equivalent. Okay, now I don't need to check any further 3 and 4. Why? Because you can see option A is there 1 and 2, option 2, 3, 3, 4 and 4, 1. Okay, so you can see 3p by 8, p by 8, p by 8, 3p by 8. So summation of all those will give you what? The p. Okay, summation of all those will give you the p, and if you bring it at the center, then because of this, there, because of this one, So you see 3p by 8 is in direction. Because of this, there will be a movement in this direction. You can see from here. And then there is p by 8 in this direction. So because of this, movement will not be in this direction. Instead, the movement will be in this direction. Okay. So this movement and this movement, so they will add up. They will add up, and then there will be a movement on the body in this direction. Final movement. Similarly, there will be a another final movement. Okay, and both the movement will get add up. So clearly this one is not similar to 1 or the 2. Okay, and for the 4 1 again same, they are like in opposite direction, so they are again not similar to each other. Okay, is that clear to you? So 3p by 8 and then p by 8, then there is p by 8 and then 3p by 8. So because of this, so there will be a movement. Okay, and this movement will be in this direction and this movement will be in this direction, and then p by 8 and p by 8. So if you bring at the center, okay, so this one and this one and this one, so there will be a movement, there will be a movement again. So there will be a movement in this direction. Okay, so again you can see neither third and nor fourth they are same, because there is p and the moment that is adding up is in the anti-clockwise direction, and the moment adding up is in the clockwise direction. So this is wrong, this is wrong, this is wrong, this one is true. Did you understand? This is very simple and very easy. There is no need to do all those things. I did all those things to make you understand, but if I would have like experience, then if I would see this one, and then I can decide directly that this will be the central point, then there will be like a movement in this direction because of that, and there will be a movement in this direction because of that, and they will cancel out each other. Now then there is another question. So 2D stress at a point P in XY coordinate system. So they have given you sigma ij, and this is sigma xx, sigma xy, sigma xy, and sigma yy, and they have given you this as 60, 50, 50, minus 40. And what they are asking, the magnitude of the tangential stress. So tangential stress means sigma xy or the tau xy, whatever you say. They are asking you that on a surface normal to x-axis. So this is x-axis and this is y-axis. Okay, and let's say this is the figure. So this is sigma xx and this is 60, this is sigma yy, and this is minus 40. So it would be inverted. Okay, and then there is tau xy. So surface, this is x direction, so this will be 50. Okay, so this should be 50, right? This should be 50. Okay, so this is very simple, and see they have asked it for 2 marks. Okay, so it is not that GATE asks always difficult questions. Sometimes they ask easy questions, and this is easy scoring 2 marks. Okay, you just need to keep your head cool, and you just need to have like calm minded. Okay, now then a structural member supports next question is this: a structural member supports loads which produce at a particular point a state of pure shear stress is 50 Newton mm square or 50 megapascal. At what angles are the principal planes oriented with respect to the planes of pure shear? So principal planes oriented with respect to planes of pure shear. Okay, so whenever I say pure shear, then this means that sigma x is equals to 0 is equals to sigma y, because sigma x is 0 and sigma y is 0 whenever I say pure shear. Only shear stress is acting at this point. Okay, and they are asking you the location of principal plane. So how do you give the location of principal plane? Tan to theta is equals to tau xy by sigma x minus sigma y by 2, and sigma x is 0, sigma y is 0, So what would that be? Tau xy by 0, and this would be undefined. So when this is undefined, so tan 2 theta is equals to tan 90 degree, and from here you can see 2 theta is equals to 90 degree, so theta is equals to 45 degree, theta 1. Okay, and then theta 2 would be 45 plus 90 degree. So theta 1 is 45 degree and the angles are in radians, so that would be pi by 4. So this would be pi by 4 plus pi by 2, and this will be 3 pi by 4. Okay, so pi by 4 and 3 pi by 4, this one. Okay, now again you can see stress area function. So they have given you phi as 5x की power 4 plus x cube y by 6 plus 3x square y square by 2 plus 7 xy cube plus e times y की power 4 by 12. Okay, the array's stress function will satisfy the equilibrium and compatibility requirements if and only if the value of the coefficient e is. So they are asking you the value of e. So you know del की power 4 or 5 is equals to 0, right? So let us differentiate this particular thing. So let us differentiate this one. So first del 5 by del x. Okay, so what would we get? So let us not differentiate like that. Okay, let us just see similarly. See, so if I try to find del की power 4 5 by del x की power 4 like directly, then what would I do? So all those terms that has x, okay, uh, so it would be something 5. Why 5? Why 5? Why directly 5? Because you know only this term has fourth power, okay, and all other term has 3 power. So eventually this term will go to 0. Okay, if I differentiating with respect to x. Okay, you have to be smart while you are trying to solve the gate questions. Okay, then del की power 4 5 del y की power 4. So if I try to find out, then what would that be? Y की power 4 by 12. So this one is there. So this will be something actually I have to also by 12, and I have to also multiply because this 4. So first this will become 4 and then x की power 3. So again this will become 3, then x की power 2, again this will become 2, then x. Okay, like this. So this will be something like that. This will be something e by 12 into 4 into 3 into 2. Okay, like this. And rest all this will become 0. Okay, and then there is del की power 4 5 del square x del x square del y square, sorry, not del square, del x square del y square. So we have to find this one as well. Okay, so let us first try to differentiate del square 5 del x square. Okay, so let us first differentiate this one. So this will become 0 and this will definitely become 0 if we are trying to find differentiate it with this one. So this will become 5 into 5 into 4. Okay, 5 into 4 into 3 x square. Okay, 5 into 4 into 3x square. Because this one first time it will give 4, then second time it will give 3, and then the power will remain 2. Okay, so that is okay, plus. So this is y by 6, okay, because we are differentiating with respect to x. So this is first time it will give 3, and then second time it will 2, and then it will remain as x, okay. And this one, so this one will give me 3, and this x square will completely vanish, so 3 by 2 y square, okay, right. And then this one will vanish because this has no. Now, so plus, okay, so this is del square 5 by del x square. Now, if I find out del to power 4 5 by del x square del y square, then what would I get? What would I get? So, I will have to differentiate this one with respect to del y square. So, this does not have any y square term. This will go to 0. This has y term. So, first time it will, if you differentiate first time, then it will give you some value. This will again go to 0. So, this will be the only one that is left. So y square first time 2 and then second time 1. So 2 cancel. So you will get 3. Right? Now you have to find out the value of e. So how you will find 5 4 are 3, 5 4 are 20, and 26. 20 times 6. So what would that be? 120 plus 4 3 are 12 and 12 cancel. So 2e plus, and this is 3 is equals to 0, right. So 2e is equals to 123. So e is equals to 123 by 2. Okay, is it clear to you guys? Is it clear to you? Okay, so that would be here. Okay, but this looks little odd. Did we make any mistake? Okay, okay, so you see we have made a mistake here, so that is 5x to the power 4 by 12, so that should be 12 here. So again you have to divide by 12, so 4 3s are 12, so this is cancelled. 5 2s are 10, so this is not 120, this is 10, okay. And this is 10, and this is not true, okay. So this is 3 by 2, 3 by 2. Why it is 3 by 2 here? Okay, so this is 3 by 2 x square. Okay, so if you differentiate it, then in the first time it will give cancel out. So 3 2s are 6. So this is 6. Okay, so guys, keep the calculation in check. Don't make silly mistakes like this. Okay, so 10 plus 6 16, and this is 2e. So 2e is equals to minus 16. So e is equals to minus 8, right. So that should be the correct answer. Now let us move on to the next part. Okay, and guys, you can check for the answers yourself. Okay, okay guys, and don't make mistakes. Now for the state of stress, plane stress is shown in the figure. So you have been given the plane stress, okay, and then what they are saying you, and they have given you the plane stress, okay, and what they are asking you something sigma x, okay. So they are asking you sigma x for the state of plane stress shown in the figure, the minimum principal stress. So sigma 2 is given. So sigma 2, how do we give sigma 2? Sigma x plus sigma y by 2, okay, and minus under root of sigma x minus sigma y by 2 whole square plus tau x y whole square. Okay, so this is how this minor stress is given, and they have given you the value of sigma 2 is minus 7. They are asking you sigma x. So what you will do? Minus 7 is equals to sigma x plus 21 by 2 minus under root of sigma x minus 21 by 2 whole square plus, sorry, this would not be plus. Yes, this would be plus and this would be minus 56 whole square. Why? Because so they have given you the shear stress in this direction. So if that is, then this would be negative. Our sign convention is like that. Okay, this is positive tau. Okay, so we are following this sign convention. This sign convention. So this is negative. This is positive. So that is why. Okay, and it does not matter if you are doing the square of negative number then. Okay, then what we will do, we will do something like this. So we will take this one this side, so this would be, and we will under root sigma x minus 21 by 2 whole square plus 56 whole square. Okay, and this would be minus 7, and this would be minus 7 is equals to sigma x plus 21 by 2. Okay, now we will do the whole square on all the sides. Okay, so we will do the whole square on all the sides, and if you do the whole square, then this will become a minus b whole square, and this will become something like that. Okay, so this is purely algebraic manipulation. Okay, this is purely algebraic manipulation. Algebraic manipulation. So this is purely algebraic. Okay, so you have to solve this on your own. Okay, so you have to solve like this only. Okay, this is the only method. Okay, and then you have to solve this like this only, and then you have to find the value of sigma x. Okay, so you guys can try to find the value of sigma x and type in the comment what is the answer you are getting. Okay, so type in comment the answer for 97, question number 97. Okay, so type in the comment the answer for question number 97. Okay, and this is all we have studied. So you see, GATE has been asking simple and easy questions, not very difficult questions. Now again this question, so and all these questions are from the aerospace engineering. I have not taken it from any other okay, so all these questions are from the aerospace engineering only. Okay, so the components of stress in a body under plane stress condition in the absence of body forces is given. So they have given you sigma xx is equals to ax square, sigma yy is equals to 12x square minus 6y square, and sigma xy is equals to 12xy, and they are telling you to find the value of a, the coefficient a, so that the body is under equilibrium. Okay, so they are asking you that the body should be under equilibrium. Okay, the components of stress body under plane stress condition in the absence of body forces. So whenever they say plane stress condition, then this means that uh, plane stress condition, then this means that stress in third direction. So sigma z will be 0. Okay, approximately will be 0 or much less. Okay, so stresses in third direction will be 0. Okay, so we will treat it as a 2D. So you already know, when we treat the body as a 2D, then what do we do? Dou sigma xx by dou x plus dou sigma xy by dou y is equals to 0, because there is no body force as well. Absence of body force. Okay, you can see absence of body forces. Okay, so no body force, so we are not going to use that. Okay, so you know, now then we have to differentiate. Okay, so if you differentiate sigma x with respect to x, so what you will get? 2ax, right? And if you differentiate sigma xy with respect to y, then you will get 12x, and this is equals to 0, right? So 2ax is equals to minus 12x, and this x and this x is cancelled. 2 6 are 12, so a is equals to minus 6. Okay, so that is how you will Find out. Okay, very easy, very simple. Okay guys, now then there is another question, this one. Okay, and what this is saying, for a state of stress shown in the figure, the normal stress sigma and on a plane inclined at 45 degrees to the x-axis is. So they have given us something sigma and this is tau as theta, sigma and theta. Okay. They have given us sigma x as 200 and sigma y as 100 and tau xy as 100. Okay, so our sign convention for tau is like this. Okay, so this is positive, so this tau is positive. Okay, so this is positive, that is correct. Okay, so this is again 100. I will write it neatly. So this is tau xy and this is equals to 100. Okay, so you have to find sigma n. Sigma n is equals to sigma x plus sigma y by 2. Okay, and this angle is 45 degree. Okay, so this is sigma x minus sigma y by 2 cos to 45 degree to theta, cos to theta, so 2 plus tau xy sin to 45 degree. So cos to 45 degree is cos to 9, cos to 45 degree is cos 90 degree, and this is 0. This entire term is 0. So and this is 1. So and tau xy is 1. So what we will get, 100 plus 200 by 2 and plus tau xy. So that is again 100. So 300 by 2 plus 100. So 150 plus 100. That is 250. Very easy, very simple. Okay, now again we have some questions that is based on the stress area function, and they have given you stress area function and they are asking you what will be the value. So this is very easy. Phi is equals to ax ki power 4 plus by ki power 4 plus c x y cube. Now you know dou ki power 4 del ki power 4 phi is equals to 0. You know that. So del ki power 4 phi by del x square plus del ki power 4 phi by del y ki power 4. Sorry, this is del x ki power 4 plus del ki power 4 phi by del x square del y square. This is equals to 0. So if that is, then they satisfy the stress area function. Okay, so now then what would be the del ki power 4 phi by del x ki power 4? Okay, so we can like see this one and we can see. So the term that does not has x will definitely be go to 0. So this term b term, this term will go to 0, and the term that is having the x term less than 4 will go to 0. This one will go, this one will be left. So a times, now first time will become 4, then 3, then 2, and then 1. Okay, so this is how we will have. So what would we get? 4 3s are 12, 2s are 24a. Okay, and if we try to find del ki power 4 phi by del y ki power 4, then again same, that we will get plus 24b. Okay, and del ki power 4 phi by del x square. So this is x, and then again it will become 0. Del ki power del square phi by del x square. So this term will go to 0, and again if we try to find del y square, and this term will go to 0, this term will go to 0. We have like 2 and del y square, then this term will go 0, so this will become 0. Okay, so we have this one as 0. 24 24, so a plus b is equals to 0. From here we can say that. So option b is true. Very simple. Now then this question, so this is This question looks difficult, but this is not very difficult. This is a very easy question. So they are saying you that they have given you this stress system. Okay, so they have given sigma x, that is 18, sigma y, that is 12 megapascal. Okay, so I'm not writing unit because they are same, and tau xy as 4. Okay, and it is according to our sign convention that we are using. So the first thing first is that you should notice one important thing. So let us read this question first. For the state of stress shown in the figure, which one of the following represent the correct free body diagram showing the maximum shear stress and the associated normal stress? So they are telling you to find the maximum shear stress and associated shear stress. So tau max is given by the formula under root sigma x minus sigma y by 2 whole square plus tau xy whole square. Okay, so what would that be? Sigma x is 18 minus 12 by 2 whole square plus tau xy is 4 whole square. So this will become 18 minus 12 is 6 by 2 whole square plus 4 square. So this will become under root 3 square plus 4 square. So 3 3s are 9, 4 4s are 16, under root 25. This will become 5. Sorry guys. So this will become 5. Okay, so this is plus. Okay, so this is positive, so all that is negative that we will remove. Okay, so there is only one negative, so we have removed that because you can see shear stress here is it is uh, in this direction. Okay, so this is negative for us. Okay, so because our sign convention is different. Okay, our sign convention is like this, so this tau is plus. Okay, so that is why we have cancelled this one out. Okay, and now you can see they are saying you that on planes of maximum shear stress. So on planes of maximum shear stress, sigma is sigma x plus sigma y by 2, that is normal stress is equal and non-zero. So sigma x plus sigma y by 2, so 12 plus 18 by 2, that is 30 by 2, this is equals to 50, and it should be positive. Okay, so you cancel this one out. Okay, because this is negative, compressive in nature. Okay, this shows compressive in nature, so but it should be tensile in nature. Okay, so this 2 is remaining. Now which one should we take? So which one should we take? So if you see the angles, okay, if you see the angles, then angles is given by tan 2 theta is equals to sigma y minus sigma x by 2 tau xy. Okay, so if you see sigma y is 12, sigma x is 18. Okay, so if you see, then angle will theta will become negative. Okay, so you have to make the negative angles. So this is x and this is y, sorry. So you have to find out the negative theta. So so this is x. So if this is like this, then theta is negative. Okay, and if this is like this, then theta is positive. This is anti-clockwise direction, so theta is positive here and theta is negative here. So which one should we choose? This one, right? So this is the correct option or correct answer. So you see, if you keep calm and if you like solve naturally, then you will definitely find the correct answer. Now then, there is another one. So for the state of stress as shown in the figure, what is the orientation of the plane with maximum shear stress with respect to the x-axis? So let us draw the figure first. So this is our body, and this is the shear stress. Okay, so this is the shear stress. This is 30 megapascal given, so it will be minus 30. Okay, and then again this is minus 20. Okay, megapascal. this is compressive nature, and then again they have given you minus 80. Okay, because again this is compressive, and they are saying you the planes with maximum shear stress. Okay, orientation of the plane with maximum stress. So they are asking you to find out tan 2 theta is equals to sigma y minus sigma x by 2 tau xy. Okay, so what is sigma y? Sigma y is minus 20, sigma x is minus 80 by 2, tau xy is minus 30. So what would that be? Minus 20 and minus plus, so minus 20 plus 80 by 2 by minus 30. So what would that be? This would become 60 by 2 by minus 30, so that would become 30 by minus 30, and that would become minus 1. Okay, so tan 2 theta is equals to minus 1, so definitely theta is equals to minus 45 degree. Okay, sorry, 2 theta is equals to minus 45 degree, so theta is equals to minus 22.5 degree. So that would become this one. This is very easy, guys, very easy, very simple. You just see, you just need to like see the sign convention correctly and then use the correct formula. So this is the formula of maximum in plane shear stress or maximum shear stress plane. Okay, planes for maximum shear stress. So this is the formula that you have to remember, this formula, and then you have to put all the values and you will get the answer. Now then there is another question, that is they are asking you the sigma and they have given you sigma x, sigma y and tau xy. So sigma n is equals to sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 cos 2 theta plus tau xy sin 2 theta. Theta is 45 degrees, so cos 2 theta would become cos 90, so this will become 0. So we can find out directly. So sigma x is 110 plus sigma y is 30 by 2 plus sin 2 theta will become sin 90, so sin 90 is 1, sin 90 degree is equals to 1, so this will become 1, so this will talk, so plus 40. So what would that become? 140 by 2 plus 40, so this will become 110 megapascal. Don't forget the unit, guys, megapascal. So guys, remember Newton per mm square is equals to megapascal. Okay, easy. Now then there is another question, which of the following statements are true about the state of stress in a plane? Maximum or major principal stress is algebraically the largest direct stress at a point. Correct. So you know sigma 1 and sigma 2, you have this one. Okay, and you know what formula we have for sigma 1 2, sigma x plus sigma y by 2 plus minus under root of sigma x minus sigma y by 2 whole square plus tau xy whole square. So sigma 1 would become, so for example, okay, so sigma 1, for example, if we have something like this minus 80 megapascal and we have 20 megapascal, then this will become sigma 1 and this will become sigma 2, although minus 80 megapascal means like this, it is compressive in nature, and this is 80 megapascal, and this means this is tensile in nature, sigma 2, sorry, sigma 1, and this is 20 megapascal and this is 20 megapascal, that is the normal stress or principal stress. Okay, but whenever we say which one is sigma 1 and sigma 2, then we definitely see it algebraically, we do not value the, so this is how it should be. So algebraically which one is larger, that will be major, so sigma 1 will be major or maximum. Okay, algebraically, okay, and sigma 2 will be minor or minimum principal stress algebraically. So the magnitude of minor principal stress cannot be greater than magnitude of the major principal stress. Wrong, because you can see this is the minor principal stress and its magnitude is 80, and definitely 80 is greater than 20. Okay, so so that is how mod of sigma 2 is definitely greater than mod of sigma 1. Okay, so this is wrong. The planes of maximum shear stresses are inclined at 90 degrees to the principal axis. Wrong again. So they are inclined at 45 degrees. You already know this. We have seen in all those calculations. The normal stresses along the plane of maximum shear stresses are equal. So that is true. We have seen sigma n star is equals to sigma x plus sigma y by 2. So they are equal and non-zero. Okay. They are equal and non-zero. Okay. So these two are correct. Now then, this question. The state of stress at a point is caused by two separate loading cases. So two separate loading cases, first and second. Okay. One of them produces a pure uniaxial tension along the x dash direction. So one of them is pure uniaxial tension. So uniaxial tension means there is only one stress, and that is tensile stress. Okay. Uniaxial tension along the x dash direction, and the other one produces a pure uniaxial compression along the y dash direction. So uniaxial compression means only one stress is there, and that is compressive stress. Okay, as shown in the figure, the sum of maximum and minimum principal stresses for the resultant stress of stress caused by both loads acting simultaneously. So they are saying that both loads are causing simultaneously. This means that you pick this one and put over it. Okay, so let us draw the figure, simultaneous figure. How do that look like? Okay, so this is x-axis and this is y-axis. So if I move x-axis by some angle theta, then that would be x dash axis, and this will become, again this will move by theta, and this will become y dash axis. Okay, and now so so this should be like this, and this should be like this. Okay, this should be like this, this should be like this. Okay, so wait a second, we correct it. Sorry, x dash. Okay, x dash. Okay, so along x dash I have tensile stress, that is 10, and along y dash I have compressive stress. Okay, so that is again 10, and then their sigma 1 is 10 and sigma 2 is minus 10, minor principal stress, so compressive in nature, minus 10, and they are saying mega Newton per mm square. So let's say Newton per mm square, Newton per mm square. Okay, and they are saying the sum of the maximum and minimum shear stress. So they are asking you the sum of maximum and minimum principal stresses. So they are asking you the sum of maximum and minimum principal stresses. So I will remove all that and I will underline only this one. The sum of maximum and minimum principal stresses. Okay. So what would that be? Sigma 1 plus sigma 2, and that will be 10 minus 10, and that will be 0. Very simple, and they are asking it for 2 marks. Okay. So you can see GATE asks some easy questions for 2 marks. So you just need to understand orientation and all. Just need to pick up this picture and put over it. So there would be like 10 and 10. So this is minor, this is major. So this is your sigma 2 and this is your sigma 1. This is your sigma 1. So now add both, this will become 0, right? So with this we have completed the tutorial. Okay, and thank you guys for being with me, and try to solve all those questions once again yourself. Okay, I may have made some calculation mistakes maybe, Okay, but that does not matter. The important thing is that you understand how to solve this and how to use this formula. So whatever we have studied yesterday, whatever formula we have seen, okay, so based on that formula we are able to solve these many questions, all these questions, okay, and this is how we are going to do and study in the rest of the chapter. Okay, so thank you.